Alright guys, what I'm going to show you here today is how to use the planar joint and constrain so that you can do something like this where you want a block to move inside of a predetermined slide or groove like you see here. So what I did was I made this block. Now, you may be asking, why did I put this cylinder on here? Well, I found that to be really important in making the constraints work a lot better. I tried it with just the block alone, and although it's possible, it's much harder to get it to align within this groove the way you want it to. So putting this here was just a game changer. So it might be something you want to consider doing with whatever type of slider block you have. It shouldn't really matter that it's there, and it just makes life easier. So now I made this part in a part file, I made the slider in a part file, and then I inserted them both, I placed them both into an assembly file. So now what I'm going to do is show you how to constrain them. So you're going to go to Joint. Remember, Joint gives you more degrees of freedom than Constrain. Constrain really locks things in and doesn't allow them to move. So Joint, for this project, moving things, having rotations and linear motions, that's going to be the majority of what we use. So click on Joint, go to the drop down, and we want to use Planar. And we're going to click on this groove. And that's why this cylinder is so important. And you can see here there's different reference points you can click on, the middle, the end, or this reference point. But we want to hone in on this seam, if you will, this groove, this intersection. Right there, so I'm going to click on that. I'm going to rotate around, and then I want to click on this seam. Again, we could click on different features here, different parts of this geometry. There's even these edges, all these different edges show up, but we want to focus on mating that groove there to this groove. And you can see they kind of match, right? So now when I click on that, you can see the animation that takes place, which is really nice to show you that it worked right. I'm going to say apply and cancel. Now, currently this is still not staying exactly where we want it, obviously. So we need to do one more constraint. And we're going to use this one for that. And it might be a little confusing. You might be thinking, well, you just say constraint locks things in. Well, it does, but because we just did this planar joint, and now we're going to do a transitional constraint, okay? And that's going to tell it to ride this edge. So if I click on the cylinder, and then click on this face, this inner edge, it locks it in place. So now I'm going to say apply, and demonstrate for you that it will not go past that point on either side. It is locked in. It will not move in any other direction. So that's really nice feature. So there you have it. Remember, I should have done this before I made all this work, but this is something I told you before in class. Before you constrain this to the slider, you want to consider grounding your base. Now, this probably wouldn't be something you would ground anyway, and everything moves, but that's okay. This isn't your base, so I'm not going to ground this.